Hi, I am Neelotpal and I am a PhD student in the Digital Manufacturing Lab, which is based in the School of Engineering, and I am supervised by Professor Charlie Wong and Dr. Bruno Adorno. Why I am here today is because my research is in some sense related to the Industry 5.0 theme of the digital futures. And in the subsequent slides, I'll try to give you a brief overview of what my research is. The topic of my PhD research is called Geometric Computing for 5-axis hybrid machine. Now, this topic probably doesn't explain much to someone who is not related to this field. So let me explain it. Consider we have a digital model of a product and some material, and we want to build the finished product. We can use a computer control machine like a 3D printer or a CNC machine to do it. Now, there are also different softwares that can help us to plan the whole process. But as the complexity of the product increases, let's say we generate a design from a generative AI tool that gives us a very complex design of any product. In that case, the traditional manufacturing or these three-axis manufacturing processes cannot be used, and we need to use multi-axis or higher degrees of freedom. In that case, sometimes the planning of the whole process becomes very difficult, and even for an experienced user, it might take hours to make the whole plan. So my research involves using geometric computing tools to make the planning easier so that even people with less experience can use the product or manufacture the product using such tools. As an example, let's consider one of our recent projects in which we developed an easy to control tool to plan the roughing stage of milling. Here you can see the user interface as well as the physical experiments. We used a vector field-based algorithm to decompose a volume into layers of material which can be removed using a tool. The project has been selected as the best paper for the 2023 ASME CI conference. This project was sponsored by 5axis Works through an Innovate UK Smart Grant. They have also used a part of this software in their new product called 5xCam. Another area in which the use of multi-axis manufacturing is really useful is in case of non-planar additive manufacturing. Here, using non-planar layers, unlike the traditional planar layers, we can improve the strength of the product, improve the surface quality, as well as use less material. And finally, we can combine both additive manufacturing and separative manufacturing to build products that involves both adding material as well as removing material to get the final product. Here you can see we are building, we are showing the video in which we build a product in which first we add some material, then we remove some material to give it a perfect finish, and then deposit some material to give it a design or some texture on it. Here I saw some of the topics that I commonly use during my research, like manufacturing, computer-aided design, computer graphics, data structures, topology, etc. So this was a brief introduction of my research. If you'd like to know more or have any question, please visit the website of our group or just drop me a mail. Thank you.